Housing starts rose to a 20-year high in November, according to a new government report.
Peak load
The
driven by
increase is
hot weather
attributed
and
to denser
excessive demand appears to be a culprit in the power
Hurricane
blackout
Katrina is
affecting a large
expected to
part of the country.
significantly raise the cost of natural gas used for heating
Energy-efficient
throughout the
building
country.
codes are being adopted
As a
in many
result,
states due to the high demand and
The
high
new
cost
energy
of energy.
bill gives homeowners a tax credit for using new low-E replacement windows.
"20 years ago, LoE coatings were developed as a way to make better insulating windows and reduce heating costs. These first-generation LoE products allow the bulk of the sun's heat to pass directly into the building. Today, this type of glass is called high solar gain LoE. Advances in coating technology have resulted in a next-generation product we call LoE squared. LoE squared insulates during the cold weather and blocks a significant amount of solar heat in the summer. This low solar gain product saves energy in the winter and can play a significant role in reducing total energy costs because it saves on cooling as well.
Cardinal Glass Industries, in an effort to verify the energy savings of their low-E products, built 2 identical homes in Roseville, California. Then 3 identical homes were built in Windrose, Texas, followed by the building of 4 identical homes in Fort Wayne, Indiana. The goal was to monitor the home's energy costs in each climate when outfitted with clear glass or high solar gain glass compared to new low solar gain low-E squared glass.
The concept behind the Roseville project was to buy 2 builder houses with clear glass, operate them side by side to prove they're identical, then switch out the glass in one house to low solar, low-E, high-performance glass and measure the energy performance difference.
Roseville, California was chosen for a number of different reasons. First is that California's a very large construction market and there's lots of building going on here. So demonstrating that these products work in a California-type environment was probably a good idea. Second good reason to choose Roseville, California as a test location is that it's a unique climate and that it has about equal amounts of heating and cooling.
I got involved in the Roseville project as the technical supervisor, and my job was to figure out how to make sure we had the houses built right and instrumented correctly so we could understand what the results were and we were sure we knew what we were measuring.
In our first phase of testing at Roseville, the energy savings matched the computer simulations.
The cost savings results in the Roseville project amounted to a 27% reduction in the cooling bill. In addition, the heating bill showed a savings of 10%. Another goal of the project was to validate that using a smaller air conditioner in conjunction with low-E squared glass could reduce the peak power demand that occurs in the late afternoon when homes have been overheated throughout the day. At Roseville, the use of low solar gain low-E squared glass and replacement of the air conditioners with smaller units of the same efficiency reduced the peak power demand by 33%. This showed that the builder could save money on initial equipment costs, while the smaller air conditioner reduced strain on the electrical power grid.
When we're working with our builders on design of their homes, the window products are the first thing we recommend an upgrade into a low-E squared product. The load calculations clearly show a benefit of those glazing products, and the air conditioner size will come down, which has many benefits, certainly in energy consumption, certainly in peak load reduction.
You know, the most important outcome to me of the Roseville project was proving in simple terms, looking at a typical production house built in a very popular area in California to demonstrate that in fact these products can make a significant difference on both the cooling energy use and that peak demand.
In the next phase of the study, 3 identical homes were built in Windrose, Texas.
South Texas has a very long cooling season and very high humidity. After construction was completed there, tests were done to confirm that all 3 homes were operating at the same efficiency. Duct blaster tests confirmed identical airflow, and blower tests quantified the tightness of each home's envelope.
In the Windrose project, there are 3 houses identical, 1,800 square foot, 3-bedroom, single-story houses, with 3 different kinds of glass. One has single gray glass, one has double gray glass, and the third house has low solar, LoE squared high performance glass. Each of the houses is equipped with a data logger which records the performance of the house on an hourly basis, or even in some cases on a minute-by-minute basis. Each room has a temperature sensor that's recording the room temperature, and we have a complete weather station outdoors that records the outdoor temperature and solar radiation and humidity. We have careful measurements of humidity in the houses and in the air conditioning system, and we have temperature data on the air conditioning system, which along with measured flows allows us to estimate the actual cooling energy delivered on a minute-by-minute basis.
The LoE glass has actually changed the way we look at load calculations. The numbers are coming out lower than what we've ever seen before, so we're having to downsize our tonnage, which saves everybody money on the initial size of the unit, plus it saves on the monthly energy cost. It's very important that the windows be good quality, because in our area, especially in Texas, the solar gain from the windows is the most dramatic effect on the house.
The use of LoE squared glass in Windrose, Texas, demonstrated similar results to those in California. The savings were over 26% in cooling costs and 33% in peak power demand when a smaller air conditioner was used. Another benefit of LoE squared glass is that it insulates in the winter. The result was an additional 11% savings on the heating bill.
The next site for our LoE squared demonstration project is Fort Wayne, Indiana. Fort Wayne is a heating-dominated climate, but like most of the northern U.S., there is a consumer desire for cooling during the hottest summer months.
4 identical homes were built in Fort Wayne, with one pair facing south and the other pair facing west. A southern exposure is desirable for passive solar heat gains during the winter, while the west orientation is the worst case for maximum air conditioning loads. The first year of testing in Fort Wayne differed from the previous work in California and Texas. A home outfitted with high solar gain LoE glass was compared to an identical home outfitted with low solar gain LoE squared glass.
Our previous projects have demonstrated the great summer performance of LoE squared glass. In Fort Wayne, we've shown that LoE squared performs great in the wintertime as well compared to high solar gain products.
The home equipped with LoE squared glass reduced air conditioning costs as much as 44%, again demonstrating its superiority in annual savings while improving comfort.
So here we are now with 1 full year of testing in Fort Wayne. We've demonstrated similar percent cooling savings as in Texas and California. LoE squared was a net winner for heating and cooling savings in both orientations. But the most important measure is the improved comfort. Year-round, we're getting a more livable house.
The comfort factor of a home can be visualized by looking at infrared thermography images. This photo was taken at noon on a sunny winter day. The right-hand window is clear glass and is very cool, as indicated by the blue color. The center window is high solar gain LoE glass. A detriment to this product is the solar heating of the room side glass, as indicated by the hot red color. Measurements in the home with high solar gain glass showed this room was overheated nearly 1,200 hours, or approximately 1/3 of the winter. At the extreme, temperatures were as high as 17 degrees above the thermostat. The left-hand window is low solar gain LoE squared glass. Notice that its surface temperature most closely resembles the interior room temperature. The same room is seen here in the evening, after the outside temperature has dropped. The clear glass window, on the right, is cold relative to the 2 LoE windows and the adjacent wall. The LoE windows are significantly warmer than the clear glass window. How significant is this difference? A room with clear glass would need the thermostat setting increased by 2 degrees to match the nighttime comfort from LoE squared glass. The key to maintaining comfort is to minimize temperature differences. LoE2 glass is warm in the winter, cool in the summer, and minimizes temperature swings from excessive solar gain throughout the year.
Window technology has advanced tremendously over the last 20 years, but it's only in the last 5 years that building codes have recognized the importance of windows in the total energy consumption of a house. These building energy codes are important to ensure that we reduce energy usage, thereby protecting the environment.
We're at the point now where about half the states have building codes that have an energy component, and that is spreading even as we speak.
The Cardinal demonstration projects, from hot and dry California to hot and humid Texas to heating-dominated Indiana, have shown that LoE2 saves on heating and air conditioning in all these climates. In the U.S., approximately 2 million new homes are constructed every year, and over 90% of them are air-conditioned when built. If all of these new homes used LoE2, the peak electrical savings from reduced air conditioning loads would be equivalent to the cost of building 5 full-size coal-fired generating plants every year. The energy savings alone would amount to every homeowner driving their car 2,000 miles less per year. But the energy and pollution savings go way beyond individual concerns. They go to the very heart of the current natural gas crisis in America. In order to satisfy the summertime peak air conditioning demands, we now burn natural gas in the summer to generate the peak demand. Unfortunately, America's appetite for comfort means we now burn more natural gas generating electricity than we do heating our homes in the winter. Cardinal Glass has demonstrated through research in test homes in 3 regions of the country that LoE2 products will positively affect the conservation of our nation's natural resources and energy future.